also known as slope fields. So a reminder that when we in advanced course did DYDX, that was the slope of the curve to a tangent of a curve at any given point xy. We're going to look at the graph of DYDX, but we're going to draw it as a set of slopes at every possible x and y value. Now we're going to focus on whole numbers for this rather than get into the nitty-gritty of decimals. And that's what you'll tend to see in exam questions. So they may introduce halves in exam questions, but they won't necessarily go all the way down to decimals. So the steps are evaluate the derivative. So if it's not given to you, then just evaluate what the derivative is using work that we've done in the past lesson. And each point, just draw a line, short line segment of the slope for each one. So we're going to construct the slope field for our first two examples. So the first one is XY, and we're only going to focus on the first quadrant just to get a bit of a sense. So here's the table of values. So the X's are on the top, the Y's are on the vertical, and when you multiply the X by the Y, that's all your values. So they're all positives, and the slopes get steeper. Drawing that as a slope field. So remember on the X and the Y axis, they were zeros, and the slopes at the various points get steeper as you go. So obviously at the point 3, 3, the slope was 9. So that's the steepest out of all of those. So that's drawing a slope field or a derivative field. What about minus x over y? So let's do the same, but let's do it from minus 3 to 3. So here's our values. Obviously y is on the bottom, so whenever y is 0, it's undefined. And x is on the top, so whenever x is 0, you get a gradient of 0. And we're just going to have a look at, if all of those were plotted, how that would look. Now, I've just put this into Desmos, so thank you to Desmos for making this a lot easier. And that's what our slope fields look like when you plot them. So hopefully you're noticing that that looks like it is a bunch of circles. And so if we were to actually look at that and plot circles, the green circle is the middle one, x squared plus y squared equals 1. You can see that passes through our two horizontal lines. The red one is x squared plus y squared equals 4. That passes through the two horizontal lines at 2 and minus 2. But the best example is x squared plus y squared equals 5. That passes through all of those slopes around. So that would be the original equation for this. So, or if you rearranged the DYDX, that would be what you would get. Sorry, for each of these. Past HSC examples. So they tend to have been mostly in the multiple choice. So here we've got from 2023, got a diagram of a differential equation or a slope equation. It passes through the point minus 2, 1. And so your job is to follow that bunch of slopes as they progress. And if you follow those through, you've got to find which one it actually goes closest to. And so following that slope, you'll notice that it gets up. It's definitely above the, it's a sort of around the middle of where the between 1 and 2. So it's around sort of 1.5, and the closest that we have there, because it's definitely above 1.5, the closest that we have as you follow crosses the axis at 1.56. So that's the best approximate for that if we follow the slopes as it follows up. For the second one, we just want to know which one the best directional field is for all of these. This is out of the 2020 exam. Apologies if this is a little bit small. You might need to zoom in on this. But for minus x over 4y. So what we would do is we could potentially substitute in values in every quadrant. So you'll notice that each quadrant's got various different ones. D has positive sort of slopes in quadrant 1, whereas in A and B have negative slopes, and so does C. So we could plot points and just see which one we could rule out. What we do know is that when y is, because y is on the denominator, when y is 0, we would have undefined. Now, none of them are clear. Not even A and B are really clear that there's any undefined on the x-axis, which is when y is 0. But the one that we're going to focus on, which actually gives us our answer, it turns out to be when x is 0. And when x is 0, that's the y-axis, we need to have horizontal slopes. And there's only one example in the whole of that that has horizontal slopes on the y-axis for all values, and that is A, and that's our solution. Thank you.